Live streaming is on. Okay, so DNA sequence are basically stored in FASTA file. Okay, so we are creating a FASTA file. So you can see that here the file name is dnasic.fasta. Okay, so nothing but I told you that DNA has basically two double helix structure. Okay, and if I so there is a special format of FASTA. Okay, so FASTA format start from the structure like from this symbol that is basically greater than symbol, and here we say sequence name. Okay, now the sequence A T G C T A C T A T. Okay, so any DNA sequence will always have four characters, either A, T, G, or C. Okay, either it will be A, T, G, or C. So A is basically adenosine, and G is basically guanine, and sorry, G is guanine, T is thymine, and C is cytosine. Okay, maybe some spelling may be not correct, so ignore that. So basically any DNA sequence is made up of four bases: adenine, thymine, guanine, cytosine. Okay, so always A will be paired with T. Okay, and T will be paired with, similarly T will be paired with A, and G will be paired with G, sorry, C. Similarly C will be paired with G. Okay, so DNA has double helix structure. So this helix is if first strand has the sequence this, so the second one will be sequence A will be paired with T, T will be paired with A, G will be paired with C, C will be paired with G, A will be paired with T. Similarly, A, G, T, A, T, A, sorry, A, T, A, T, A. Okay. So if first strand has this sequence, so the second strand will be this sequence. Okay. Now this is called second strand. This is called the complementary sequence. Complementary sequence. Okay. So if I told you to create the complementary sequence of this, then the complementary sequence of this will be this. Okay, so if I told you to calculate the adenosine base in this DNA, so you will calculate adenosine. How many times here adenosine is? One, two, three, four times. Okay, so here number of adenosine is four times. Okay, similarly, how many times T appeared? One, two, three, four, five. So here five thymines are present. So this is basically our simple introduction about DNA. Now, our goal is to create and first create a DNA class. Okay, so first create a DNA class, and properties of DNA will be number of adeno, number of A, T, G, C. Okay, so first, we will have four properties, number of A, T, G, C in this DNA sequence. Okay. Second property will be sequence of DNA. Okay. And Third will be length of DNA sequence. And fourth is valid DNA sequence. Okay, so I told you that DNA sequence will have only four characters, either A, T, G, C. So only four characters are allowed: A, T, G, and C. Suppose that if someone replace this T by D, then this is not a valid DNA sequence. Okay. So so fourth property of this DNA class will be is valid DNA sequence. Okay. So let's start. We are creating a new file DNA dot. Okay. So DNA dot py. Now we will be creating a class DNA. Okay. Now we need to write properties of this DNA. So first property I told you that sequence. So sequence. Okay. So sequence is one. Second property will be number of adenosine is equal to none. Third property will be number of thymine. Okay, is equal to none. Fourth will be number of cytosine equal to none. Fourth will be number of guanine equal to none. So this is basically referring for A. This is referring for B. This is referring for C, and this is referring for D. And next will be length of length. Okay, simply length. So sixth property is length, and last one is valid. Okay, I am creating one more property, so I will explain this later. Okay, so first we need to create the sequence. So first we need to create a constructor. So if init, so here you will pass the sequence of DNA. Okay, now we will assign this sequence value to sequence. So we'll write here self dot sequence is equal to sequence. Now if we need to create here get length. Okay, so get length self return self dot length is equal to length of self dot sequence return self dot length. Suppose that I am not writing this here, I'm writing this here. Now to get the length, we are just return length of return self dot length. Okay, and this self dot length will be length of our DNA sequence. Now our second method should be is valid. Okay, self. So to check is valid, we need to check that this DNA sequence should have only A, T, C, G. Okay, so only four characters should be in this DNA sequence. Okay, so First, I am creating a variable bases allowed. So which bases are allowed? Basically, there are four bases are allowed. That is A, B, G, and C. Okay. Now, is this clear to everyone?
Yes, sir.
Okay. So, if you have any doubt, you can ask. So, we will move forward. If you have any doubt, you can ask. So no one has any doubt. Okay. So to check that is valid DNA sequence, so we need to check that this sequence should have only these characters. So we will write four bases, four bases in what sequence? Self dot sequence if. Okay, so I'm writing this base for base in self dot sequence if base in what, if base not in self dot bases allowed, then return. Okay, so we can say it here self dot is valid is equal to what, false. Otherwise this is a, otherwise this is what, otherwise this is a valid DNA sequence for base in self dot sequence if base not in self dot bases allowed, then self dot is valid is equal to what, false. Otherwise is valid will be what, true. So first I am assigning this self dot is valid is equal to, suppose that true. But if this scenario happen, then it will set the value to false. Otherwise you will get the result true. Return self dot is valid. So why it is giving error? Okay, so we have here. So I'm giving this is valid sequence. Okay, so is valid sequence. Now I need to change this. Now we don't have any error. So so we created here a method that is valid. Okay, so here we are doing what? First we are telling that our DNA sequence is valid, but we are checking now for base in self dot sequence. If base not in self dot base is allowed, then we are setting this as false, and in the last we are returning self dot is valid sequence. Okay, so now next we wrote the method to get the length and check this is a valid sequence or not. Okay, so first try this. Okay, now we need to get this also. Get number of adenosine, get number of thymine, get number of cytosine, get number of guanine. So we need to get this also. If get number of thymine. Okay. To get the number of thymine, we need to return what? Self here and self dot number of thymine is equal to what? Self dot sequence dot. Is there any method to count any number of character in a sequence? Do you know that? Okay, so someone is telling that we can call the count. Okay, let's try. Okay, now we need to return self dot number of cytosine. Sorry, self dot number of thymine. Okay, now I'm creating an object of this. Similarly, we similarly get number of thymine. Similarly, as get number of thymine, we can create the method to get the number of adenosine, number of cytosine, number of guanine. Just we need to replace this T by different character. Okay. So first I am creating the object of this DNA. So DNA1, I am telling this DNA1. This object name is DNA1, and I'm creating this and passing a sequence ATGCT. Okay, now I am taking print DNA1 dot. Okay, so is valid, and again I am taking print DNA1 dot get number of thymine. Okay, so this is not the method self dot sequence dot count. I think this is spelling error. I think this method is correct. Okay, so now we are getting true, and second it is telling that 2. Okay, so you can see that here we call the method get number of thymine and we are getting 2, and in the first case we are getting is valid, DNA1 dot is valid, and we are getting here true. So you can see that here why it is a valid sequence. Why? Here we have only ATGCT, means here only which bases are here, A and T and G, and similarly C is also present. Suppose that I am changing any base by B, so it is not a valid DNA sequence. Now it will give you false. It is telling that false. Okay, so this is not a valid DNA sequence. Is this clear, everyone?
Yes, sir.
So similarly, get number of times. Similarly, we can create the method. Okay, so I'm not creating method for this. You can create, okay, by yourself. Just I am giving you the example of this. Now one more property that I want to add here, one more method, that is get complementary. Okay, so I told you that complementary is nothing but you need to change the A by T, T by A, G by C, and C by G. So, so any DNA sequence has the complementary like this. Okay, so if you place this here, okay, so you will get what? A always align with what? A always align with T. Similarly, T align with A. Similarly, G align with C. Okay. Now this is how alignment is done. No, this will be not an alignment because this is an error. No. You can see that how this alignment is performed. A will be aligned with T, T will be aligned with A, G will be aligned with C, C will be aligned with G. Okay, so A and T will align itself, T and A will sorry, G and C will align itself. So to get the complementary, we don't need to do anything. So I am creating a method here, def get complementary sequence. So to get the complementary sequence, first we need to check what? Self if not is valid. Okay. First we need to check self dot is valid. Give me 1 minute. Okay, so first we will check that if not, here we have variable is valid sequence. Okay, so if not, self dot is valid sequence, then we will get the complementary, otherwise we will return error. Okay, so to get the complementary of it, first I am creating a property here, complementary sequence is equal to none, and then we are writing here self dot self dot complementary sequence is firstly empty. Now for base in self dot sequence, if base is equal to a self dot I am creating a variable here, complementary sequence is equal to And okay, now I am telling that self if base is equal to A, complementary sequence will be T. Tell if base is equal to what? T, then complementary sequence will be G. Tell if base is equal to G, complementary sequence will be what? C. Tell if base is equal to C, then complementary sequence is equal to G. Okay, now in the last, here we will find which what will be the complementary sequence of the current base, and now we need to append this. Okay, so here we will type self dot complementary sequence plus is equal to complementary sequence. Okay, now we need to return self dot complementary sequence. Okay, so initially self dot complementary sequence will be none. Okay, now you can see that here we need to here in this if this should be written in this if. Okay, so it should return, otherwise we need to return what? Otherwise we need to return in not a valid sequence. Okay, there is an easy way of doing this, so we can use that also. Now I think this is it is complementary sequence method clear to everyone. So we have one very easy solution for it, and we will use that. But now I am using this simple approach. Okay, so adding here DNA one dot get complementary. Uh, okay, okay. So it is giving you the complementary sequence T G C G G. So A will be aligned with T, T will be aligned with no. So T should be aligned with
You have written the G, so
okay, okay. So T will be aligned with A, G will be aligned with C. Okay. Now we have T A T G A. Okay. Now, so it is difficult to compare this. So I am printing get sequence. Have we written any method to get the sequence? No. Okay. So we are adding a method here. Def get and self we are returning a return self dot sequence. Okay. Now I'm calling print anyone dot get sequence. So okay, so this was the original sequence and this is complementary sequence. So A is aligned with T is aligned with A, G is aligned with C is aligned with G, and T is aligned with A. So there is an easy way of doing this also, and we can use that. So we could have simply replace the A character, every A character with T and every T character with A. Similarly, every T character with every G character with C and every C character with G. Okay, so this was a very simple approach. There we will not use if else, and also we will not use for loop. So which program is more efficient? I think this should be more efficient. Okay, so if you can find which program is more efficient by running this for a large DNA sequence, it would be better. And there are some approaches by which you can basically only one way. There is only one way of checking your program is efficient or not. Is that by running the program for larger test cases. Okay, so create a DNA sequence having let's say 10,000 DNA sequence. Okay, and try to run by using two different approaches to get complementary sequence, and you can find which program is more efficient. Okay, so so this is a so we will do more on this, and I am just creating a simple DNA class, and you need to implement the number of thymine, number of cytosine, number of adenosine, and also you need to create a different get complementary sequence. Okay, method to get the complementary sequence. Okay, and after that we will this is lecture one part of the DNA sequence. This project is large, and I will explain the half I will explain the part two of it in next class. Okay, so get sequence here line number 25 and 26. Okay, so we will connect tomorrow again. Okay, thank you everyone, try to practice on this. Do you have any doubt on this?